This is the lesson for 6-7, Transformation Combinations, Day 2. Today's lesson is a little bit weird because you're not actually graphing anything. You're taking a look at graphs that are already there, and you have to figure out what exactly is going on. Are we doing a translation and then a reflection? Are we doing a dilation and then a rotation? Are we doing a reflection over the X, then a reflection over the Y? What exactly is going on? So this is a good page to keep in mind. When you go to put in your answers today, you have to be specific. You can't just say, oh, it's a reflection and then a rotation. All right. When you say that it is a reflection, if you look in this red box, you have to say whether it's over the X axis or over the Y axis. You can't just say that it's a reflection. When you say that it's a rotation, you can't just say that it's a rotation. There are 3 different kinds of rotations, and you have to say which kind it is. Is it 90 degrees clockwise? Is it 180? Or is it 90 degrees counterclockwise? Remember, clockwise goes around like the hands of a clock. Counterclockwise is backwards clock. Translations. When you say that something is a translation, you have to say how many places you're sliding it left or right. So left or right, and then a number. And then how many places up or down. So up or down, and then a number. When it is a dilation is the only one that makes it bigger or smaller by multiplying. So when you say that it's a dilation, you have to say of how many. That number is what you're multiplying by. So if you're multiplying by 2, it would be of 2. If you're multiplying by 1/2, meaning that it's getting smaller, you would say of 1/2. So you have to be specific when you say whether it's a reflection, rotation, translation, or dilation. So let's take a look at some of these. I just put those 4 words right at the top so you can keep in mind of what the choices are. All right. But then remember, we have to be specific with it as well. Please remember, and this is super, super important for today, please remember that in all of these questions, you are going from A to A prime. When we get to the combination ones, you're going from A to A prime to A double prime. So these first ones are starting off just to get you used to being specific. So we're only doing one thing on these first, I want to say about 10 examples or so. All right, so take a look at this first one. How are we getting from this triangle to this triangle? All right, what are we doing here? Are we doing a reflection? Is it that mirror opposite image? No, it's not. Is it turning? Well, no, the triangle is facing in the same direction. We have the A at the top, the A at the top. It's not turning. Is it a translation or is it a dilation? Is it a dilation? Is it getting bigger or smaller? No, it's not. It's the same size, so it's not a dilation. Therefore, it has to be a translation. And now, again, when you write the word translation, you have to be specific. You can't just put translation. You have to say how many left or right, how many up or down. So let's take a look at going from A to A prime. So to get from here to here, I have to go 1, 2, 3 places to the right. So I'm going right 3. And then, so right now I'm right here. And now I have to go 1, 2, 3, 4, 5, 6, 7 places down. So it is a translation of right 3 down 7. Again, you have to be specific. Let's take a look at this second one. So we are going from this triangle without the primes to this triangle with the primes. Some people like to number them like this just to know how you're getting from one to the other. But remember, you're going without the little apostrophe to with the little apostrophe. So when I take a look at this one, I can see that it is that mirror opposite image. It's being flipped over this line. All right, it's being flipped over that line because it's that mirror opposite image. Therefore, it has to be a reflection. And now again, with reflection, we have to be specific. Did we reflect it over the x-axis or did we reflect it over the y-axis? Well, this is the line that we're reflecting it over. This is your x-axis. So this is a reflection over the x-axis. Let's take a look at the next ones. So when we take a look at this one, we're going from this triangle to this triangle. So is it a reflection over X or Y? No, it's not. Is it being turned? Yes, it is. All right, this one is definitely being turned. Notice that we're moving 2 quadrants. So this is a rotation. And since we're moving 2 quadrants, it is a rotation of 180 because we're moving 2 quadrants. When it is 180, you don't have to say clockwise or counterclockwise. It's just 180. Take a look at this next one. I can see that it is clearly getting bigger or smaller. Now we're really going from this small one to this big one. So the only thing that gets bigger or smaller is a dilation. And now you have to figure out how many times bigger is it getting. Sort of one of the little cheater ways that you can do this, if we take a look at A and A prime, one of the ways, besides looking at the sides, now this one doesn't go horizontal or vertical at all, so it's hard to tell what you're multiplying by looking at the sides. So one of the other ways to do it is to look at the coordinates. If I look at the coordinates of A right here, the coordinates of A are 0, 2, over 0 up to 2. The coordinates of A prime are 0, 6. Well, how do you get from 2 to 6? What do you have to multiply by to get from 2 to 6? You have to multiply by 3. So this is a dilation of 3. Whatever you have to multiply by, that's the number that goes here. Again, you could look at any of the coordinates you wanted to. If I looked at B, I'd be looking at 1, 0, and 3, 0. Well, how do you get from 1 to 3? What do you have to multiply by? You have to multiply by 3. Or if I looked at C, it would be -1, -1 to -3, -3. How do you get from -1 to -3? Again, you have to multiply by 3. Take a look at this next one. All right. How do we get from this triangle to this triangle? Remember, we always go from the no prime to the single prime. So how are we getting from here to here? Is it a reflection? Is it a mirror opposite image? No. Is it a rotation? Is it being turned? No. Is it a translation? Is it being slid to the right? Yes, it is. All right. We're sliding to the right. So this is a translation. And again, you can't just say translation, you have to be specific. I already said that we are going to the right. So let's figure out how many to the right. If we start at F and go to F prime, I'm going 1, 2, 3, 4 places to the right. And then I'm going 1 place down. So a translation of right 4, down 1. If we take a look at this next one, I can clearly see that it is a flipped opposite mirror image. So that means that this one is a reflection. And now you have to be specific over what axis. Well, this one went over the x axis. That's the line that we're counting to and counting from. Take a look at this next one. So how do we get from this one to this one, the no prime to the single prime? I can clearly see that this is being turned. The only one that turns something is a rotation. And now you're going from here to here. So we're only moving 1 quadrant. So that has to be a rotation of 90. But we have to say whether it's clockwise or counterclockwise. We're going from approximately 8 o'clock to approximately 5 o'clock. So we're going backwards clock. So this would be 90 degrees counterclockwise. Remember that counterclockwise is all one word. Take a look at this one. I can clearly see that this is that flipped opposite mirror image. So I could draw that line right down the middle along the y-axis. Therefore, this is a reflection over the y-axis. The y-axis is what I'm counting to and what I'm counting from. For example, you would be 1, 2 places to that line, 1, 2 places away from it. Let's talk about 2 more. So in this one, we are getting smaller. Notice that this blue shape is bigger. The green shape is smaller. The only thing that gets bigger or smaller is a dilation. Now, how much bigger, how much smaller? So there's 2 different ways that you can figure it out. You can look at the coordinates or you can look at the length of the sides. If we take a look at this side right here, QR, QR is 6 tall. Q prime, R prime is 3 tall. Well, how do you get from 6 to 3? You're taking half of it. 3 is half of 6. So this would be a dilation of 1/2. If we took a look at the length of the bottom here, the length of the bottom is 8. The length of the bottom here with the primes is 4. 4 is half of 8. Or we can look at the coordinates. Q is really 5, 2. Sorry, 4, 2. 4, 2. And Q prime is 2, 1. Well, how do you get from 4, 2 to 2, 1? It is half the size of the original. Let's take a look at this next one. How do you get from the black to the red? I can see that it's being slid. So this is a translation because we are sliding the picture. How much are we sliding it? Now you can pick any letter to any letter prime. That's the same letter. I'm just going to pick these 2 because they're very close to each other. J to J prime. I'm going from J to J prime. I'm going right 1, up 1. So right 1, up 1. Let's do 2 more. All right. I think the dilations are sort of the hardest one. You can figure it out that it's a dilation right away because it's the only one that gets bigger or smaller. But figuring out the of part is a little bit more challenging. So again, you don't have any horizontal or vertical lines here. So I would look at the coordinates. I'm going from 2, 1 to 4, 2. How do you get from 2 to 4? You multiply by 2. How do you get from 1 to 2? You multiply by 2. So this is a dilation of 2. Now, this last one, we are turning the picture. All right, we're turning the picture. So therefore, it is a rotation. We are turning it 2 quadrants. Since we're going 2 quadrants, it is a rotation of 180. So the types of questions that you're going to have on your homework today look like this. You have to make sure that you are going from A to A prime to A double prime. So again, I think that it's a good idea to go through and number your pictures so you know where you're going from what to what to what. So we're going from this blue triangle to the red triangle to the purple triangle. Now, to get from blue to red, to get from the no prime to the single prime, am I doing a dilation? No, they're staying the same size. Am I doing a reflection? No, it's not a mirror opposite image from blue to red. Am I doing a rotation? Am I turning it? No, they're pointed in the same direction. Am I sliding it? Yes, I am. So this one would be a translation. Now, to get from A to A prime, I'm going 1, 2, 3, 4 to the right. That gets me to here. So I'm going right 4. And then I am going up 1, 2, 3, 4, 5, 6. Now, that's not your final answer. All right. That's the first part of the answer. Now I need to figure out how I'm getting from the red one to the purple one. It might be the same thing. You might have a translation, then a translation, but most of the time it's different. So I can see that this is a flipped opposite mirror image. All right. It's being flipped over this line right here, which is our y axis. So the next thing that we're doing to get from A prime to A double prime is we are doing a reflection over the y axis. So this would be your complete answer. Take a look at the next one. So again, I think it's helpful to number your triangles. You're going from the no prime to the single prime to the double prime. So we're going from blue to red to purple. To get from blue to red, I can see that I'm turning it, all right, because it's upside down. Notice that I'm going 1, 2 quadrants to get from blue to red. So therefore, it is a rotation of 180 because I'm moving 2 quadrants. Then to get from red to purple, notice that it's getting smaller. So it has to be a dilation. How much smaller is it getting? Well, it was 4 units tall. Now it's 2 units tall. To get from 4 to 2, you would have to take half of it. So it's a dilation of 1/2. If we took a look at the coordinates instead, if we looked at like C prime and C double prime, C prime is at -4, -2. C double prime is at -2, -1. So it's half of the original. And that's it. So that's what you have to do today. But make sure that you are specific when you are describing what you're doing.